Good afternoon, students. Welcome to this video segment. In this video segment, we shall add and subtract polynomials. And we shall just do these 5 questions as examples. Hopefully, if you can understand this, if you do understand these 5 questions, then you should be able to solve other questions, similar questions as well. Now, let's just have an overview of adding and subtracting polynomials. When you deal with polynomials, you deal with functions of variables. This is not like in arithmetic. Arithmetic, you have numbers, right? Arithmetic, you only have numbers. 3 plus 5. It gives you 8. You deal with only numbers. You know, -3, -5 gives you -8. Right? Okay. Now, but when we come to algebra, then we now start introducing alphabets. Those alphabets are what we call variables. Those alphabets are what we call variables. But guess what? The way you do arithmetic is still the same way you do algebra, right? Algebra came from arithmetic. The principles you use in arithmetic is the same principles you use in algebra. Now, when we come to algebra, that is when some people start wondering, okay, what am I going to do with letters? Now, you just have 3p plus 5p. You see, you have introduced the word p, but that p shouldn't be a problem. The p could be anything. It could be pen, it could be pencils. So 3 pencils plus 5 pencils. You wouldn't say 8, because if you say 8, 8 could mean anything. 8 could mean 8 markers. 8 could mean 8 shoes. 8 could mean $8. But you will now say 8 pencils, right? So this will now give you 8p. That is the only thing that you now notice differently here. Now, if you also have -3p, -5p, it will still give you -8p. You now have to put the p. The same way goes to a. If you have 3a plus 5a, it still gives you 8a. So that is the principle you will learn how to use here. Now, what if we have 3p squared? 3p squared plus 5p squared. Right? In this case, you now have p squared. P squared. And this will give you still 8p squared. Now, what if you have 3p squared plus 5p? Now, in this case, you notice that 1 here, in this, the base is p, the exponent is 2. Here, the base is p, but the exponent is 1. So, you don't see them as identical variables. Okay, we can factor them, but that is not what we want to do now. We don't want to factor now. So, we just leave it as that, 3p squared plus 5p. Because here, this is p squared and this is p. Okay. Let's do more examples so that you can kind of get familiar with it. What if we have 3p plus 5? Here you have algebra, you have a variable. Here you have a constant. It can work. It's gonna still be 3p plus 5. What if you have 3p plus 5g? Now, this is 3p. P might be pencils. 3 pencils plus G might be gates. 3 pencils plus 5 gates. Pencil plus gate wouldn't work. It's not going to work. So you still have 3p plus 5g. I just want to kind of, so you can understand the way it works. Now, in arithmetic, when you have 1 plus 1, it gives you 2. The same thing applies here. When you have p plus p, Now, why did I say p plus p? Why did I mean p to as if it's 1? You know, now p is not 1. You know, some students get confused on that. P is not 1. It's just taken as 1p. For example, if I tell you, James, may I borrow pencil? If I just say, James, may I borrow pencil? If I don't say, may I borrow a pencil, I didn't put a pencil. I just said, James, may I borrow a pencil? Now, what do you think James will be talking about? How many pencils do you think James will give me? Just 1 pencil. So, if we just say p, it means just 1p. That's what it means. Right? So, this becomes 2p, just like you have 2 here. So, these are the kind of things you need to kind of get familiar with before we do this. Now, on a general note, when you see variables, they have the same base and the same exponent, that is when you can add them or subtract them. But if they have different base or different exponents, just leave as is. Leave it as is. So let me write this on a general note. On a general note, only add or subtract, right, variables with, number 1, the same base, and number 2, the same exponent. Else, or otherwise, leave as is. Now, this is the principle which I use for this topic. Add or subtract only the variables with the same base, same exponent. If it does not, you leave as is. Another thing is that it will be good you have an idea of distributive property, because we are still going to use them here. It's important here. Okay, so this general case is that when we have something like x squared plus 3x squared, right? Of course, this is a constant that is attached with a variable. Let's look at the variables. Let's look at only the variables alone, right? Let's look at the variables alone. X squared here, and let's look at this x squared. So now, what do you think is here? If, like I said, if I say, James, may I borrow pencil? P, it means 1p. So this means like 1x squared. That is what it means, 1x squared. So if you look at this, it has, the base is x, the exponent is 2. Now, I hope that when you look at this is known as the base, and this is known as the exponent. Yeah, if you view my videos on exponents, you will understand I covered this aspect. So the base is x, the exponent is 2. Here the base is x and the exponent is 2. So when you look at the variables, right? Look at the variables. If they have the same base and the same exponent, all you need to do, you can add their constants or subtract their constants, as the case may be. Now, you should also watch my video, view my video on addition and subtraction of integers, so that it's easy to know about this. So you now look at this. This is like saying 1 plus 3, and this gives you 4x squared, right? Another way some people might do is they bring out the x squared. When they bring out the x squared, they now have 1 plus 3. X squared times 1 plus 3. And that gives you x squared times 4. And that gives you 4x squared. But for now, we are just concerned with this. This is what we are concerned with for now. So you just add it, and it gives you that. Another way you can say it is just And that way you can say, or you can write, let x squared be dollar sign. Let x squared be dollar sign. And this is like $1 plus $3. And that will give you $4. And you change it back to x squared, 4x squared. I mean, if you want to just simplify it further. So you have many ways to kind of, solve this type of question, and you're expected to reason with that. Now, let's look at another one before we now solve the main problem. Let's look at another one before we solve the main problem. What if we have maybe x squared plus 3x? Again, let's identify the variables here, right? X squared and then x. Of course, 3x, some people will say is a variable. It's actually constant times a variable. Yeah. But let's just pick out the variables here. Now, here the base is x. The exponent is 2. Here the base is x, but the exponent is 1. So in this case, just leave as is. Leave as is. Leave as is. X squared plus 3x. Now, later on when we do factoring, you can still factor this. When we do factoring, and if you factor it, it will be x is common, then x plus 3. But that is not what we are concerned now. We don't want to talk about factoring now. We just want to add the identical variables. Okay? Add or subtract identical variables. Let me now write this. Add or subtract, only add or subtract identical variables. Identical variables. That is, variables with the same base and the same exponent. That is what we are concerned about now. Okay, folks, let's go ahead and start. Let's go ahead and start. Number 1. We have a x squared minus 4x plus 2 plus x squared minus 2x minus 8. Okay, if you look at this now, what is the, what is the number here? This is assumed to be 1. 1. And this is assumed to be 1. When you have something in parentheses, it's assumed to be 1. 1 times that. This is very important. It's assumed that you distribute 1. So what you can do is, 1 times x squared. 1 times x squared will give you x squared. 1 times negative 4x will give you negative 4x. 1 times 2 will give you positive 2. Then plus, you now want to open up this parenthesis. 1 times x squared will give you x squared. 1 times negative 2x will give you negative 2x. 1 times negative 8 will give you negative 8. So this is like just doing 1 times this to give you this. And then 1 times this here to give you this. That's kind of how we did it, to open up the parentheses. Then, once we finish doing this, you want to get at the identical variables. You want to get the variables with the same base and the same exponent. And this will now be x squared plus x squared, because this, now, you don't want to change signs. You want to get it with the sign that it has. This is not an equation, this is an expression. This is a polynomial function. It is not an equation. You don't see any equal sign. So do not change signs. Get it with the sign. So then you have negative 4x, negative 2x, and then plus 2 minus 8. Another thing is that you might ask me, why would you start with x squared? Why don't you start with negative 4x? And that's a good question if you ask that. Why do I do it? It's good to start, in descending, decreasing powers of x, decreasing powers of the variable. We always want to start with the decreasing powers of the variable. You start with x squared, x raised to power 1, then x raised to power 0. Remember that x raised to power 0 is 1. Okay, so we want to start with 2. Then of course, you know that this is 1. And of course, you know that 2 minus 8 means like 2x raised to power 0 minus 8x raised to power 0. So we want to start in decreasing powers from the greatest to the least. The polynomial functions should be ordered. It should be in a certain order, either increasing or decreasing. Increasing means from smallest to highest. Decreasing means from highest to smallest. But we always want to start in decreasing order just to maintain that order. Okay, so that's why we have it with x squared first. Yeah, and we don't need to put x0, x0. We know that this is 2 minus 8. So once you have this, x squared plus x squared will give you what? Just like 1x squared plus 1x squared. That's what it means. 1x squared plus 1x squared. This is 2x squared. Here, you owe 4x, you owe 4 xylophones, and you owe another person 2 xylophones. Remember when I taught add and O? It's just like doing -4, -2. You owe 4, you owe 2. That means you owe 6. So that's the same thing here. -6x. And then here you have 2, you owe 8. You have $2, but you owe me $8. -6. And that becomes your answer for number 1. Okay, number 2. Number 2, you have 4x squared plus x minus 2 plus -8x squared plus 7x minus 3. So the same thing here. This is like 1 here, 1 here. That's the same thing. So distributing 1. Open up the parentheses. 1 times 4x squared is 4x squared. 1 times plus x is plus x. 1 times -2 is -2. Plus 1 times -8x squared is -8x squared. Plus 1 times plus 7x is plus 7x. Plus 1 times -3 is -3. And then this will now be 4x. You get identical variables. Get identical variables together. 4x squared minus 8x squared. Keep it with the sign. This is an expression, not an equation. You are not transferring from left to right or from right to left. No. Then plus x plus 7x minus 2 minus 3. You have 4x squared and you owe 8x squared. You have 4, you owe 8. That means you owe 4. -4x squared. You have 1. X means 1x. You have 1, you have 7 plus 8x. You owe 2, you owe 3 minus 5. That becomes the answer to number 2. Okay, now I would like you to pause this video and do number 3 on your own. Pause and do number 3. Pause the video and do number 3 on your own, then you check. Now in number 3, we notice something different, but it's still the same principle. Now what do you notice a bit different here? This is now -1. But it's still the same principle, okay? This 1 here, 1 here, -1 here. 1 times x squared is x squared. 1 times -4x is -4x. 1 times -6 is -6. Then here, -1 times 5x squared is negative 5x squared. Negative 1 times 6x is negative 6x. Negative 1 times negative 11 is positive 11. Let me repeat this aspect again because some students kind of mess up with this. Now, for this one is, you just write 1 times x squared, 1 times negative 4x, 1 times negative 6, right? So this gives you x squared minus 4x minus 6. Now this one, you have to be a bit careful. Negative 1 times 5x squared, because you're distributing now, this is negative 1 actually, that's what it means. If you have a parenthesis like this, here means that 1 is in front, right? So negative 1 times 6x, and then negative 1 times negative 11. So that's how we got all this. Negative 5x squared, negative 6x, and then positive 11. And here, x squared, negative 4x, negative 6. So it's kind of good to be familiar with this, okay? And then we now get the like terms, x squared minus 5x squared minus 4x minus 6x minus 6 plus 11. You have 1, you owe 5. That means you have 4. You owe 4, you owe 6. You owe 10. You owe 6, you have 11. You have 5. That becomes it. Okay. Pause the video, do number 4 on your own. Pause the video and do number 4 on your own. Number 4, we have 7x squared plus 7x minus 7 minus negative x squared plus 3x minus 1. Okay, this is still our 1 here, and this is still our 1 here. If we don't have anything in front, then it's still 1. That's what it means. Now, sometimes we do have something in front. Sometimes we do. But here, it's still 1 and 1. So 1 times 7x squared is what? 7x squared. 1 times 7 plus 7x is plus 7x. 1 times negative 7 is negative 7. Negative 1 times negative x squared. This is negative 1 times negative x squared. Negative 1 times positive 3x. Negative 1 times negative 1. So negative 1 times negative x squared is x squared. Negative 1 times 3x is negative 3x. Negative 1 times negative 1 is 1. So just for you to kind of, if it means that you have to write it this way so that you don't make mistakes, please do so. Okay, please do so. So this will now be negative 1 times negative x squared is positive x squared. Negative 1 times positive 3x is negative 3x. Negative 1 times negative 1 is positive 1. So this will now be 7x squared plus x squared. You want to get identical variables. Plus 7x minus 3x minus 7 plus 1. You have 7, you have 1. That means you have 8, 8x squared. You have 7, you owe 3. That means you have 4, 4x. You owe 7, you have 1. That means you owe 6. Right? Okay, the last one. Number 5. 3x squared plus 4x minus 8 minus 6, parenthesis 6x squared minus 3. So of course, you know that we have 1 here, we have 1 here. Right? So 1 times 3x squared is what? 3x squared. 1 times plus 4x is plus 4x. 1 times negative 8 is negative 8. Negative 1 times 6x squared is negative 6x squared. Negative 1 times negative 3 is positive 3. Get the like terms together. 3x squared minus 6x squared plus 4x. Now if you look, 4x doesn't have a brother in the second polynomial. Okay, 4x doesn't have a brother in the binomial. This is a binomial. This is a trinomial. So 4x doesn't have a brother there, so you leave it. You don't worry about it. Then negative 8 plus 3. You have 3, you owe 6. That means you owe 3. 3x squared. You have 4x. It doesn't have any other brother. You leave it like that. You owe 8, you have 3. That means you owe 5. And that becomes the answer. Thank you for listening to this presentation. I hope you understood what I taught. If you have any questions with what I just did, please feel free to send me an email, okay, or call me, whichever one. Thank you for listening, and you have a good day.